over this session, so I'm going to go ahead and get started. And if anyone filters in, they filter in. So thank you all for attending. Today we're going to be talking about the future of AI and development at Salesforce. This presentation was going to cover a vast amount of developer topics until I saw all the questions that were coming in. And so I've been able to shift the presentation a little bit, and we're going to be able to go in pretty deep on a lot of the future developments at Salesforce and hopefully show you some content that we have yet to see. So before we get started, I do have to show you our forward-looking statement. We are going to be talking about a lot of new features and functionality that are not yet generally available. So please make all of your purchasing decisions based off of our currently available products and not our future features and functionality that we're going to be talking about today. Now, to start out, I'd just like to introduce myself. So I'm Stephan Chandler Garcia. I'm Director of Strategic Content at Salesforce within our developer relations team. And what does that mean? What does it mean to work on strategic content? Well, I get to build a lot of really cool stuff at Salesforce, whether that be building our giant keynotes, building demos, building GitHub repos to share out our code, writing blogs, and speaking of code, writing a lot of code. It's one of our principles on our team to make sure that we still spend 30 to 40% of our time coding while also creating all of this content to make sure that we're hands-on with the technology and that we are solid developers, because we need to be able to show that we can innovate on the platform just as much as the people that we're talking to. But I am just one part of a very big team. I'm sure you'll recognize some familiar faces on here. We have Danielle and Philippe, who are both here today, and we have a giant audience relations team at Salesforce. This is just looking at admin and developer marketing, let alone the wider trailhead teams that we work with, teams that sit around our organization like the architect team, and it's our job to inspire trailblazers to build great content and be successful within their companies. Now, what we're going to talk about today really centers around artificial intelligence and how you as developers can start incorporating that technology into the things that you're building. And we're going to talk about exploring some of the general concepts of generative AI and how they apply to you as people who are building on the platform. We're going to talk about actually building these applications and what you can do using code-based and low-code solutions already to start using this. And we're then going to talk about the wider future of innovation when it comes to artificial intelligence and what a lot of developers are already doing to bring these really innovative, highly technical solutions to their businesses. Now, we're going to start out with talking about generative AI in general. Now, I hear it's someone's birthday today in the room. Is it you? Is it your birthday? No. Today is the first anniversary of ChatGPT. Okay? It is unbelievable to think that it's only been a single year since ChatGPT was launched as an application that we can sign up and use. Okay? In the last 12 months, obviously we've seen a spike in acceleration and adoption of these generative AI solutions into our workflows, into our companies, but there's a long history of AI innovation across the enterprise space, including here at Salesforce. Now, if you're in the room here, if you've used a feature like Einstein case classification, the vision APIs over the last years, raise your hand. So who's used one of the declarative Einstein features? No one. Okay, we've got one. We've got one over here. That's crazy because they're some of the coolest things that we've put out as a solution that are really baked into the platform in setup. So you can go into setup, you can turn on Einstein case classification, and you can train your own model today on your case types. Now, that feature started as an API. Okay, when we launch our AI features, generally through the years, we've released them to developers first to adopt and build to see how they use. However, the adoption was low. It wasn't until we started baking these user interfaces into our products that people then started bringing the technology and using it in their companies. We have tools like the prediction builder, Einstein case classification, and many more features that we've incorporated over the years. And that just goes to show that we have all of this time to learn how to bring a lot of these applications of AI into enterprise companies. Now, if we talk about generative AI, you'll notice all of the features that we're building first are in setup. Okay, they're all baked into the product. not set up for developers yet. And that's because in the past, developer adoption of artificial intelligence has been surprisingly low in the Salesforce ecosystem versus business and admin adoption of these features. So we are now building and baking the product into what we're building and then focusing on being able to extend the capabilities of them and give access to developers to build these tools. Now, we all know what generative AI is. I'm hoping everyone in the room has used ChatGPT and understands what it sort of does. But holistically, you give it an input in the most basic form, a text-based prompt. Okay, we're going to refer to prompts quite frequently today. A prompt is the input to a large language model that teases out a response. Okay, that response can be text-based, image-based, audio-based, okay, and constructed based on how the large language model interprets that prompt that you're putting into the model. Now, what's the difference between what we've already been doing around predictive artificial intelligence versus generative AI and large language models? Well, number one is a vast difference in scale. When we talk about predictive AI, we're talking about features like Einstein case classification that are taking in a number of cases, subjects, descriptions, and case types. Okay? It's a very predefined input that isn't a very large data set, and you know exactly what you're getting on the other side. You're going to get a case type. Okay? Predictive AI takes a really strict, prescriptive, predefined input and provides a predefined output. Whereas a large language model takes in the entire internet, okay, to train, giant sets of data to train. And the economies of scale are huge, and we see that with companies like NVIDIA, who can't produce enough GPUs to train these models and to continue to grow a lot of this technology because the processing power is ridiculous. Okay, now, like I said, what makes this difference, number one, is more data. We're talking about gigantic data sets versus smaller subsets of very specific information to train on. We're talking about better algorithms. This technology has grown massively in the last 10 years. And companies are able to construct and put together much more complex algorithms that can almost self-train themselves to get better and better as humans and machines start to interact with it. And the compute power is far more vast than has ever been needed before to train these models. Now, this is incredibly powerful technology. And as an enterprise software company, we need to make sure that we're using it correctly and safely, as well as our customers are using it correctly and safely. And we're doing this by inherently sort of putting 4 generative AI principles in front of our customers and in front of the technology when we're building it to ensure that what comes out is safe and secure. Obviously, as a company, you've heard a million times our number one value is trust. We need to make sure that we have a trusted relationship with our customers and our partners, including the people who are building these large language models. And we need to make sure that it's clear when content is being generated by that. Okay, you will see in our user interface, there is nowhere that you will see a magic generative AI response in the back end. Okay, it's always clearly presented. And as developers, and as you start to build this technology, it's important that you take that on as well. And when you're building generative AI-powered features, you're clearly indicating that the results are being generated from Einstein. Okay, security is important. We're going to really deep dive into that in a minute with the way that we're implementing a secure foundation around how we interact with large language models. Okay, we need to ensure that they are accurate, and we are making and taking as many steps as possible to ensure accuracy is provided, because the second an inaccurate generation is shown to your users, is shown to your customers, if you're putting these features in front of customers, that trust is lost, and the business could lose revenue. So we need to ensure that before these features are generally available, they're tried and tested to make sure that the results that they're providing are accurate for you and for your customers. And lastly, we need to make sure that this technology empowers users. It's incredibly powerful, but it's not always right. So we need to make sure that when we're building these applications, when you're building these applications, they're in assistance to the people who are going to be using them, who are going to be relying and doing a better job with this technology. Now, the more important question to ask, and the only one that I'm sure most of you care about, is how you, as developers, build with AI. We're building all these applications internally at Salesforce. We're creating all these APIs. We need to make sure that you have access to them and that you can bring AI into everything that you're building. So The easiest way to bring a large language model and create a generation within your business is through APIs. It's a myth that every business is going to need to train their own model because it's expensive, you probably don't have enough data, and you're never going to get the same results as these large commercial model providers are getting. Companies like OpenAI, Anthropic have been doing this for a very long time. They have the foundational technology, they have the GPUs, and they have the data. And so companies across the world, developers across the world, are using their APIs to get to market faster. Now, there are many challenges in doing this. Obviously, being here in France, you have to abide by rules and regulations that mean that you can't even send data overseas when it contains personal information and get a response back. And that is going to be the largest problem for a lot of people when it comes to this, because OpenAI in particular, all of their servers are in the US. So as a company, if you're just integrating Salesforce into OpenAI, you're sending PII over a connection. The second you hard code that endpoint into your org, you're probably sending PII over to the US, which is against the law. And that's why as a company, we've introduced the Einstein Trust Layer, which is really our key differentiator to incorporating this technology into the platform so quickly. Now, I like to think of this as being that full pipeline that prompts run through before they come back to users and the data is actioned. Now, there are a few phases in which this process happens though, and I like to sort of class them in 3 different areas. We start off sort of with the before generation process, where we need to take that prompt, that input to the model, and we need to make sure that it's safe and secure and enriched with the correct information before it actually hits our partners here with these models. And so there are a few steps that happen here. Now, the first thing that we need to do with our prompt is ensure that it's grounded and has the correct amount of data in it to generate a meaningful response. Bear in mind, a lot of these models that are commercially available are only trained up to a certain date. So for example, OpenAI, GPT 3.5, which we're currently using, is only trained up to about mid-2021. So we use a technique called grounding to enrich that prompt with relevant information that the model may not have access to. So if you're trying to create a generation around something that happened today, you need to give the model context of what today is, of the company, of their cases, of their opportunities, in order for it to make a generation that is valuable to your users. And we do that in a 2-step process, first called secure data retrieval, which will enrich your prompts with the context of the current record or page that they exist on. And that prompt is then hydrated based off of that existing page context where the prompt is generated, or the server if it's generated from the server. But bear in mind, every single call to an LLM made by Salesforce through one of our applications or the trust layer goes through this process. There is not a single time on the platform that a generation will occur that this process doesn't happen. So we want to make sure that that data is fresh every time it hits the prompt. Secondly, when we go into this dynamic grounding, we're going to be giving you the opportunity to enrich the prompt with even more data. You can use tools like Flow to incorporate business logic and the ability to query across records and relationships to enrich the flow, which we'll demo in a little bit. Okay? Or use tools like data graphs inside of Data Cloud to pull even more data into those prompts. Okay? We then go through the process of data masking, and this is where it's really important here especially when it comes to ensuring that there is no PII going across that connection. Bear in mind, in its current release, it is only in English, but multilingual support for the data masking is going to be coming in a pilot in the next release, and we should look forward to that continuing to accelerate really quickly because our customers across the world are looking to adopt these solutions. Okay, but what it's looking for is personally identifiable information, okay, compliance information around credit cards and processing, and there are currently 17 specific data types that it's searching for. Now, we're using an in-house machine learning algorithm that we've built with our research team to run that prompt and its entire context through that process to mask the data, okay? And as that occurs, what will happen here is any personal information, whether it be about the user, about the customer, will be replaced with key pair identifiers so that when that data is finished processing, we can go back and rehydrate it with the correct information. But we want to make sure that companies like OpenAI aren't even getting the personal information in the first place, so there's no possibility for that to be sent over the connection. From there, we go through and add a set of prompt defense heuristics or system-level prompts to the prompt that is being sent to the server to prevent things like prompt injection and to ensure that the responses are presented in a proper and safe format for an enterprise company. Now, this is all just in preparation of what's going on. I'm sure you've seen the stories around people trying to hack ChatGPT to get it to do malicious things. Obviously, there are people who are trying to get it to create bombs for some reason and create chemical compounds, etc. All of that information is flagged, and we do our best to try and prevent it on the Salesforce side, but you'll see there are multiple steps through the process to continue prevention of the creation of malicious content. Now, once that prompt has been crafted, it's then sent over into the models. Now, there are 3 different ways or types of models that this interacts with, okay? Number 1, we have our own hosted models here at Salesforce. Currently available to customers is CodeGen, which we use to power Einstein for developers. That is a model that we have created in-house and are running in the trust layer within our own trust boundary. We then have the ability to bring your own model, currently only available with Data Cloud, but going to be expanded to work with the trust layer as well. And then we have external models like OpenAI and our partners that we're working with to develop extensions into the trust layer as well. Now, it's worth noting that we have 0 retention agreements with our external partners to make sure that no data is shared or stored or retrained on based on the agreements between us and, in this case, OpenAI, and going forward with any of our future partners. So there is no chance that a prompt, any of the context, any of your business critical information is stored within the models, except for in one case. If there is a malicious prompt that comes through the system, OpenAI does flag that and notify Salesforce. So if someone in your company is trying to take advantage of this technology in a bad way, trying to get into your Salesforce org, whatever, that is flagged by OpenAI, and then we are notified. Okay? Once that process is complete and a generation has been created, so it's written our thing for us, it's created whatever piece of content we've asked it to, it then goes into a process after the generation before it's presented to a user. So that response is, number 1, flagged for toxicity. We run it through another algorithm to categorize it to ensure there's no harmful, hateful, inappropriate content as part of the prompt, and we flag it. If it's found, we do not show it to the user, and we just show them an error message instead to say that the prompt couldn't be generated, and then log it internally. Okay? Then the data is demasked. If the prompt is saved, it will then take those key pairs, rehydrate the data, so that then it's safe to show with a user full of context. At this point here, after the demasking, it is shown to our user. And at that point, they can provide feedback on the generation to showcase whether or not it was successful, whether it was valuable, or if it wasn't what they were expecting. Now, I heard this question asked earlier, and if you want to know whether or not we're actually using that feedback to retrain, so in the instance that you're using an external model like OpenAI, any feedback is logged for internal use, but not provided back to our third-party partners. If we're using an internal model like CodeGen, which we host within the Salesforce trust boundary, that feedback is taken. So if you're providing a thumbs up, thumbs down, comments on that, the next time we retrain the CodeGen model, we are going to be incorporating the feedback provided. Now, all of that feedback is going to be stored in a data cloud database in your org, so that your administrators have access to the generations and the feedback, so that you can obviously provide it, but also take advantage of it, view it, see what users are generating, and fully audit those transactions if anyone's having trouble with that. And at that point, we're done with the trust layer. Now, like I said, just to reiterate, every single generation that comes through your org, whether it be from Einstein for developers, whether it be from our sales or service apps, whether it be from the APIs that we're going to be releasing, every single generation runs through this process. Now, we're lucky here at Salesforce that we started replatforming to Hyperforce. I know there was a session on it earlier. I know quite a few of us already have orgs on Hyperforce, and it's really important to note that we would not have been able to scale this technology out this quickly if we didn't have that power of Hyperforce sitting behind us. And what you're seeing here, you're going to hear a lot in the next few months, and it's us really talking about the Einstein 1 platform. Okay, the Einstein 1 platform is us repurposing and rebranding the way that we use our metadata across Salesforce to start to include and extend into all of our other cloud platforms, like Marketing Cloud, like Commerce Cloud. You will start to see little facets of these applications coming onto the core platform, because we really believe that our secret sauce as a company is having that metadata capabilities to extend and build out applications for developers and admins. And we want to make sure that Einstein and Data Cloud are a solid part of what that platform is in the future. And you will see that we've baked in this open model ecosystem right into that platform. Because if you think about what's happened with OpenAI over the last couple of weeks, what happens if they were to be taken over by Microsoft and we were no longer partners with them? Maybe if Microsoft is closing down their enterprise APIs. We're set up perfectly to work with any LLM provider. Okay, so when you're bringing your own LLM, when we're building out our platform, we've built this in a very holistic way that we can just plug and play providers as the marketplace changes over the years to ensure that you have 100% business continuity going forward. Now, what does this mean? So I'm going to show you now how you as a developer can access that LLM gateway from anywhere. So say you want to make a call from the trust layer. I'm going to show you how you can do it really quickly and easily in Apex. So I'm going to pop over to VS Code now. Okay, what you're seeing here is the Einstein LLM Generations API. Okay, this is currently built on top of the Connect API so that you can create generations from anywhere in your Salesforce org. I do have to note that this is currently in a private beta with a small number of ISVs, and the syntax is changing when it's going to be released to all developers. Okay? Currently, like I said, it's using the Connect API. It's actually going to be moving over to its own Einstein namespace because there are a lot more features coming going forward for this. We're also going to be offering REST API capabilities if you want to use the trust layer in your external apps. But in its simplest form, what's happening here is we're instantiating the LLM API here. Okay? We can pass in an input. We can set config, like the max number of tokens that we'd like to accept or return, and then we can provide a response. Now, that's as simple as calling this single method in a single line of code and generating a response from anywhere. So I'm going to go ahead and click execute, and while that runs, I could be calling this through a Lightning Web Component, I could be calling this from Flow, I could be calling this from anywhere. Anywhere that you can write code in Salesforce, you can call the LLM gateway directly. And so I've gone ahead and asked Einstein GPT, why should I attend French Touch Dreamin? And it's written a nice 4-line list of reasons why I should attend the event. Keep in mind, this is only up until 2021, so it doesn't know whether or not last year's event was a success, so hopefully it would still provide the same type of response. But I just wanted to show you that it's this easy to start calling and bringing this into all of the apps that you build. And I'll start to show you how this expands and grows as we go on through this presentation, because this is just the very most simple example of using the LLM gateway, but we are using it throughout Salesforce, and there's lots of cool functionality on the roadmap. So popping back over to the slides, I now want to talk about building applications using all of these tools and how we're looking at generative AI applications and how they're constructed. Now, if you talk to our UX research team at Salesforce, they're going to tell you that the future of Salesforce is a text box. You're going to log into Salesforce and you're going to see a search bar, and your users are going to ask, what should I do today? And it's going to tell them. Now, we all know as developers that that's not actually how this works, okay? Sometimes we let them run with their ideas and they'll go crazy. Now, as a developer, a lot of times I'll say, I'm just going to put the LLM gateway in some triggers in the back end, and no one's ever going to interact with it. It's just going to know what to do every time. And we know that's not the reality either. It's going to end up somewhere in between, where there is some user interaction with an LLM, there is some process that happens in the background, but for the most part, I don't think the user interface that we're using is going to change. There may be a few more chatbots, but in general, the structure in which we're building business applications has stayed stagnant for many years now. The way it's presented has changed, but a page of fields is pretty much what a lot of companies still need to see. Now, there's a sort of a 3-phased approach that we've been using at Salesforce to implementing these applications and that we've seen. it all starts out with 12 months ago when ChatGPT was launched. I had many colleagues, I know you all had many colleagues who were using ChatGPT in your companies to do some of your work. You were storing prompts in Google Docs and sharing them across the company. I know people who were copying and pasting their Salesforce data to summarize into ChatGPT. And in the end, it was creating pretty insecure responses that were training on data. I know there were a few code leaks as well for companies who were just pasting their code into ChatGPT to try and get a response, not realizing that they were inherently retraining the models that were being presented to other users. Now, that's where we started, and I like to categorize that as external applications of AI. You were using an external service 100%, but still using your proprietary customer data in that transaction cycle. Now, where we are today is embedded experiences. Now, we have built applications for your users inside of Sales Cloud, inside of Service Cloud, like email generation, service replies. Okay, those applications are, like I said, built into the UI. Okay, they're grounded in code. You have no access to those prompts. Okay, they're either written in Java or Apex, somewhere back behind the Salesforce sort of curtain. Okay, all those prompts are saved in code, but the winner here is that the data is processed by the trust layer. So everything is happening within that Salesforce trust boundary to the point of calling the third party. But like I showed you a minute ago, it's pretty secure going into that third party and coming back. Now, where the future is extensible, just like the rest of the Salesforce platform. We need to make sure that you can extend all of the applications and capabilities that we develop. For example, every new team that's building generative AI functionality is being told to write prompts that can be modified in Prompt Builder, okay, to use this capability so that you can extend it. We're building tools that you can use as well. Like I showed you that Connect API, all of our internal features are being built using that Connect API endpoint. And it's the same functionality that we're going to be exposing to you. Now, we get into this three-phased approach where eventually everything's customizable, but we're not there yet. We're getting very close to that. And the first iteration of giving you that extensibility is the Prompt Builder. Okay? If you've had a chance to see the Prompt Builder in a demo before, I'm just going to cover some of the basics now, but it's a tool that helps you write prompts. It helps you ground them in a current record context, and then, like I showed with the trust layer, helps you provide that dynamic grounding into the prompt as well. Don't forget the prompt is what we're sending to the LLM. So this is helping us really craft that input to the LLM. Now, it lets you do quite a few things like tweak the tone, add many specific parameters. You can see how the prompt's resolving, etc. I could talk about this, but once again, this is a developer keynote, so I'm going to show it to you. So we're going to pop into an org. I've been lucky enough to hold some hands-on workshops around the world the last couple of weeks, continuing into next week, and really get people's first impressions of what it's like to use the Prompt Builder. And it's been pretty great to see people's faces light up when they're using this technology for the first time. So this is V1 of the Prompt Builder. Okay, it's currently in pilot with quite a few of our customers. You can see here we have this prompt workspace where you can start writing a prompt, providing it inputs, and then providing that external data. In this case, you can see here we're passing in an account name, and then we're passing in a flow, and we're grounding on open cases for the account. Okay? This prompt is what we'd call a field generation prompt. This prompt will be used to help us populate a record within Salesforce. So when you're on an account page, you can edit the page, and you can use generative AI to populate the fields. Now, this is going to run every time based on that page context. So the first thing I'm going to do is go ahead and select an account here. We have one here called Global Provisions. Let's see. Okay, I can then preview this response. So what it's going to do is take that record ID, pass it in through the server, get the record data, ground the prompt, and then provide a response. And so here you can see, I can zoom in a little bit for you. We have the company name here as asked for in the prompt, and then we have an array of cases. It's important to note that a lot of the models, like OpenAI's GPT 3.5 or 4, can interpret the array as intended, and so it can take that raw data and still provide a response. We can then go over and see here the response that's been provided. We can see Global Provisions is a company that specializes in providing a wide range of food products, yada, yada, yada. Okay, it's been able to generate that for us in the org. Now, where is this used? I said this was to help us generate a field value. Okay, in the page setup, you can go in and specify a page and a record to use a prompt. In this case, when I go in and edit the page, you'll see here I have some little magic buttons. Okay, this data is provided by that prompt template. So I can go ahead and click that here, and what it's going to do is take my prompt, it's going to ground it on the page context, it's going to dynamically ground it with the flow data, and it's going to create that response for our users. So that we can take that, we can refine it, I can ask this to make it shorter, or we can just use it, and pass that value over to the record for our users to edit. This is incredibly simple. This is a very simple way of doing this. But what happens if we want to make it a little bit more complex? So this is the spring version of Prompt Builder that's going to be coming in the next release. You'll see it's a much bigger workspace. Okay, it's full screen in an app, no longer in setup. You can do more, and you can target more places with these prompts. In this case, this prompt has been built to be called from Apex. Okay, I want to be able to take the prompt I've created, I want to pass in a record ID to it, and I want to be able to go and run that anywhere. So in this case, if I go into Apex, let's go back into our project here, minimize that. Okay, what I'm doing here is generating a response with a prompt. I'm passing in the prompt name and an ID. Again, the syntax is changing in the next release, but this is just to give you an idea of what's possible. So let's go ahead and execute that. Oh, hold on, it's not going to let me. Okay, that's going to run here. And hopefully, without fail, we have our completion. Okay, and there we go. So it's gone ahead and generated a response in Apex using that prompt, giving us a full company overview directly from, in this case, anonymous Apex. It's that simple to then take those prompts that we've crafted using the tools provided, and now we can call that anywhere. The perfect example of this is from a Lightning Web Component. So I've written an LWC here that just generates an account overview. Pretend in this case you have an account manager that needs to just know a high-level summary of everything that we've done with this company. We can press Generate Account Overview. This is a custom component I've built myself, and it's going to go and use that code to generate this for our user. Okay? I've been able to take that and run it behind the scenes to process it in the LWC. Imagine throwing this into a trigger, enriching every single account record that's created so your users don't have to see it. There are so many use cases for bringing this into the stuff that you're building as developers that you can really get started to build some cool new stuff. Okay, so that's how we build today. I want to talk about how we can build in the future and how companies are really starting to innovate with this. So forward-looking, there is no demo in existence yet, so we're going to get really technical on some of the high-level concepts around this, and then take a look at some code that has nothing to do with Salesforce. So there is a new role approaching in the developer world. Obviously, we've had researchers and data scientists for some time, and traditionally, they're the ones that are doing the work to write the formulas, write the algorithms, and then implement them using technologies and languages like Spark, for example, to build out these frameworks, okay? And then on the other side, you've got the full stack developer who takes whatever it is. Once again, calling back to Einstein case classification, it's not that complicated to say, here's 3 fields, and then here's a response based on those 3 fields. Like, it's pretty trivial. But when you start having these APIs from multiple places that do all kinds of crazy things we've never seen before, there's been this emergence of what I like to call the AI developer. This new person who's doing things like orchestrating LLMs and bringing together these frameworks and all of this new technology to craft perfect responses. They're implementing and maintaining tools like vector databases to personalize LLMs and create even more specific responses to your use case. And they manage infrastructure and support all of these. I mean, we're talking hundreds of frameworks. Some examples of those are LangChain. If you've had a chance to play with LangChain, it's a really, really cool way to bring together all of these actions that can occur around an interaction with a large language model. Okay. Vector databases are also a new hot topic, taking either documents that you're providing, full-scale databases, and vectorizing them so that you can then interact with them in the process of working with an LLM. And the way that this sort of takes shape is in three distinct ways. Number one, we've already talked about using APIs. There are hundreds of APIs available for using and building LLMs. A lot of LLMs you can even run locally on your machine now. There's a great framework I learned about a couple of days ago called LLM that literally lets you access any of these from your command line on your local machine incredibly easily. Now, the next part of this is where it gets a little bit more complicated. There's a process that's really emerged on top called retrieval augmented generation. And what this is the ability for you to pretty much augment that prompt so much so that when it hits the LLM, it knows everything that it needs to know about your use case and about your business. It's the process of taking what data you have, vectorizing it, and then giving the process, in this case, like a LangChain, access to that vector database to enrich that prompt as it's going to the server. And it's using those vectors to incredibly quickly search through very large databases inside of that process. Now, when you provide that type of information to the LLM, you're going to get incredibly personalized responses, which I'll demonstrate in a moment. Now, the next part of this is that AI orchestration. And this is where we're really seeing the most innovation and will impact you the most as Salesforce developers. It's about taking those prompts and using the prompt itself to identify what actions an LLM needs to take. So instead of just providing a text-based response, it's predicting what it's going to do and what it's going to do for a customer or for a user. Now, the best way to illustrate this is to assume that you've given access to this orchestration tool many actions. You've given it the ability to to query a database, to update a database, to call out to APIs, and many APIs, and even more APIs. Like, you can give it actions and the ability to do anything. So for example, if you needed to answer a question about an order, you could query, you could update, you could generate the response, and you could send it to the user. Or in the case that you needed to update the shipping address of an item, you would need to query the order, okay? You would need to update the order. You would then need to send that to, I don't know, FedEx or DHL to let them know that they've changed their shipping address, and then you'd have to generate a response to the user, okay? This isn't like futuristic technology. This is already happening. Companies are already doing this with LangChain to orchestrate these actions and creating these AI-powered assistants. Now, this seems incredibly far-fetched, but I'm going to show you a really quick example of this in action. Now, one of our colleagues, Julian Duque in Developer Relations, built this great app that takes the entire Salesforce developers YouTube channel, vectorized it so that we could answer incredibly specific questions about Salesforce development from OpenAI. And so let's go ahead and take a look at the code real quick. So what we have here is a JavaScript project that's implementing LangChain.js, which is a JavaScript port of LangChain. You can see here we're importing OpenAI, we're importing PG Vector, we're importing a text splitter, we're importing prompt templates. All of these capabilities are those actions and those skills that we're providing to the application. You can see here, when it comes through, we construct the prompt template, we give it the very specific responses that we need, we enrich it and we search the vector database, and we generate a response. Okay, I'm not going to get into this too much, and I'm going to show you what this looks like in action. So here we have just a Swagger spec on the screen. We've got two methods here. We can load and we can query. So if we wanted to load new YouTube videos into the vector database, we could. But in this case, I'm going to go ahead and try it out and put the mic down for a moment. What we want to do here is ask it a question about Salesforce. So here's one. We've all wanted to know and had to re-Google how to use fetch in an LWC. So let's go ahead and ask our application. So what it's going to do is take that question, it's going to run it through the vector database, it's going to find an answer that may be relevant, it's going to add that into the prompt, and then it's going to go ahead and generate our result using OpenAI. And here we go. To use fetch in a Lightning Web Component, you need to import it. It's provided some code, but what's even more important here is it's provided a reference. So HTTP requests from the LWC using the Fetch API in Developer Quick Takes, and provided the video example of where that information's come from. So in this case, we've been able to augment the LLM with our information. That's incredibly cool. Imagine if you could do that with the data in Salesforce. Well, that AI developer, that super important set of skills that's emerging, do you have to go and hire one? Do you need to become one? Of course not, because Salesforce is your AI developer in this tool chain. We have like a third of the company who are already experts at a lot of these frameworks and tools, who are using them to extend and build on the platform. Now, if you've heard of Einstein Copilot, if you paid any attention at Dreamforce, that's what it is, okay? It would have never been explained like that because that's way too technical for Dreamforce. But when we talk about that AI developer, when we talk about vectorization of databases, when we talk about LangChain, Einstein Copilot is that tool for you, okay? What it's going to do is take the questions that you're asking from core applications, the processes, it's going to make a plan, okay? It's going to take that question, it's going to take all of your actions that you already have in your org, like standard and custom actions, invocable methods, flows, and it's going to determine which of those things it needs to execute in order to solve the problem. So when you say, can you update my order, it's going to query for orders, okay? It's going to update the order, it's going to hit the external service to the API, and it's going to provide a response back to the user to say, hey, great, we updated the response. Now, that plan is being generated by AI. The connection of those objects is being generated by AI. And the way that we're exposing this functionality is through, in its initial capabilities, an internal chatbot that's in your Salesforce org, but there are plans to take this everywhere, to Experience Cloud, to URL addressable copilots. Like, these things are going to be everywhere. Now, for us as builders, we've built the Einstein Copilot Studio so that all of this is configurable from the start. Number one, oh, I thought I went through all of these, but I'm going to talk to them because I'm doing a 90-minute session in an hour. So there are 3 parts to this. Number one is the prompt builder. I've just shown you that. The prompt builder is what we're already using and deploying to users to build prompts to create more intelligent responses. Now, those responses are only a small part of what a copilot is. That's what's happening when it's generating text for someone or something. But more importantly is the actions. You've already written hundreds of actions in your orgs. You've written invocable methods, flows, you have external services, all of these capabilities. One thing that you can do now to get ready for copilots is go and make sure that your descriptions are filled out, because the metadata around your configuration is going to be more important than ever in this process, because the AI model needs to be able to go and interpret the things that you've built so that the planner knows what it needs to do to execute. And then the third part of this is the model builder, which we shown earlier today in the data cloud section. But the model builder is going to allow you to incorporate third-party models from companies like AWS. We have some capabilities that we're bringing over from tools like CRM Analytics, Einstein Discovery, that will allow you to build your own smaller models on your org, bring your own models through APIs and endpoints, etc. And this is really all part of Copilot and how we're starting to expose all of these capabilities at a real granular level so that you could take advantage of all this new technology that's in existence in the world without being someone who has spent years working in AI and AI research. Now, that's it for today around how we've learned to explore the foundations of generative AI, how we can actually start building on this technology once we have access within our orgs, and how we can then innovate with Copilot and all of the frameworks that we have coming in the future. Now, we have lots and lots of AI content as well as other developer content at developer.salesforce.com. Our team own and maintain this website. So please check it out for weekly blog posts covering the latest for developers, the Salesforce Devs YouTube channel, and we are at events all around the world. I think Danielle and I are both in Chicago next week. I'm running a workshop in New York. There's a workshop in London on Monday. We are everywhere. So check out the latest on our Twitter handles, on our websites to catch us wherever we are. Thank you very much.